MLflow, which is from Databricks, was actually pretty early on one of the key sort of parts of the GenAI building block sandbox. But the problem, or they started out more in the machine learning sort of part of building systems, and then they realized that a lot of people were wanting the same functionality, but for GenAI. And so we were following up with MLflow throughout this period, and today we're seeing that it's the far more mature way of building an AI agent in 2026. And we are pretty certain that it's going to be one of the biggest competitors for stuff like LangChain going forward. I want to talk about three sort of main benefits of using Databricks and MLflow for GenAI production. And I want to start off by talking about modularity, which I've already mentioned before. So modularity, for at least me, means being able to build something that you can have a bunch of different building blocks and then change and intertwine whatever is working and what's not working based on the needs that you have. Because a lot of times we see that you start out by scoping and defining a project, and then you realize that that scope or that project description is changing over time. And without a proper modular system, you're getting stuck in the past. For example, with LangChain, where you have to rely on something that's built but not scalable to whatever you're working on. One of the main benefits of Databricks is that this sort of modularity is in the DNA of what they're building, meaning that they want us to be able to have a lot of different use cases that we can all rely on the same system in the backend for. This is Unity AI Gateway. I think it used to be called AI Gateway, and then it was called something else. They have a lot of names for things they love in Databricks. But this is a way of getting a model that you need and changing it out to whatever else that is better for your use case. So all of these different models here are hosted by Databricks. And the benefit of that is that you don't really need to think about what kind of AI API keys you have. You don't have to worry about what kind of output they're giving or their structure or anything. The only thing you need to think about is what your endpoint is called. This is really powerful for building and rapidly advancing when you're trying to do a proof of concept of something that you want to make sure works. And if you look at it from the in the code, you can see that it's really easy to just change your endpoint name to whatever that you want to try out. Creating your chatbot like this, and then getting the response from here. So this is really nice for us, and we saw this a lot when we were working at V, where we're able to really quickly change out and see, okay, there's a new AI model coming out. Is this better? Does it perform better than the one that we used to have? And then a lot of people maybe have their own ways of serving models, or they don't want to use something that's from Databricks. This might be because you're not really in a place where you can just give out all of your data to a server in the US or elsewhere in Europe. And so you want to have something that you can either run locally or run on cloud infrastructure that you already have. And so you can simply, as you see in the bottom here with OpenAI, this is from Azure. So you can just host whatever you want in Azure and then have that endpoint point to whatever you're making at the time. And then you can also make your own models that are defined by the use cases of your project. Finally, I want to show the artifacting, because I know a lot of people who work with GenAI in Databricks don't actually know about this. But MLflow has this feature where you can see the underlying artifacts of your models. And you can get the code from whatever custom agent that you built, as well as the input examples and the conda files and everything for your agent. And you can version control this, and you can share it to other people when you're developing your agent. We found this really useful to making sure that whatever we built was as good as we could get it. I didn't have a really good word for this, so I just called it closeness to the data layer. But essentially, what we found is that the closer you are with your AI application to whatever data that it relies on, the better you're able to create your system in a fast and create a good system, a good quality system. So I'll talk about what I mean by this, but we see that whenever you create GenAI systems, you want to have as good data as possible. But good data isn't really what good data used to be. The definition has changed. So having something that is, if you take a table, for example, we realize that normally you have something where you just have a gold layer that's really well scrubbed and useful for your application. But nowadays, you actually need better documentation for all of the column names. You need metadata for all of your tables. And you need to have more and more information to give your agents when they're using the data that you have. And then finally, I want to talk about data governance because I've become sort of a geek for data governance because I think it's really interesting. You don't have to read this too much, but this is from the GenAI playbook that Databricks developed. And on the left part here, you can see the users of your system. So take, for example, you have a platform team and an analysis team, and they're all using the same agent application. Now, if the platform team has different types of data that they should be able to access, your AI agent shouldn't be able to figure out, or your AI agent should be able to figure out what you should be able to see and what your coworkers should be able to see. And we think about this the same way that we do users. So in Databricks, you can define roles, and you can define filters about who should have access to what data. And you can actually inherit this type of access control to your agent so that you don't have to have two different types of data governance systems built. So everything is unified, meaning that you don't have to worry about whether your AI agent is going to give you information that's sensitive to different people in your organization or users. This makes it so that when you're an AI agent or AI engineer, you're not responsible for your AI system giving out information about your company that shouldn't be there. And so there's a link to the GenAI playbook. I highly recommend reading through it because it's really valuable for a lot of this kind of system development. Okay, the third part I want to talk about is evaluation. That's, for us, what we realize is the most important thing in getting something that's working, and especially when you're trying to create something where you don't only want to create a proof of concept, but something that's a proof of value. I think everyone has heard about the statistics where 95% of AI agents or AI pilots fail within the first year. And my strong belief is that it's because they're not testing their system. I've talked to people here in Oslo that's been working on GenAI systems that have been touched by thousands of people in Norway with huge ramifications for the systems where they'd never even tested it beyond trying it out in a notebook and seeing if it works. I don't think that's a good way of testing your product, especially when it's sensitive to what you're building. So we have developed a philosophy in Knowit for building these kinds of systems. And everything I will tell you about it can be exemplified by this photo where you work as a scientist and a researcher trying to experiment iteratively on what you're building to make sure that you have data to back up whatever you're trying to convey. So because these GenAI systems aren't like traditional systems where you have a known number of inputs and a known number of outputs, you don't really know what kind of crazy things people will tell it, and you don't know what kind of crazy things people will hear from it. And that's a big problem because you don't really know how to test an infinite amount of variations. But that's when we saw that the more sort of stochastic and the nature of your system is, the more important it is to have something where you can have structure and rigidity to your testing. One of the ways that you can do that is by having numbers, getting something that you can quantify and measure to make sure that you're testing and developing for the right application. So if you have users that are satisfied or not satisfied, that should be measured and quantified as soon as you can to make sure that you actually know if you're steering the ship in the right direction or not. This is one of the examples from Databricks where you can see how MLflow is built for this kind of evaluation. This is my favorite part of MLflow. I'm not getting paid by MLflow or Databricks to be here, but I do want to say that I really, really, really love this feature because whatever your users say is getting tracked, and you can drill deep into what they're saying. Are they satisfied with the answer that they got? How did their agent figure out that answer? And you can do stuff like LLM as a judge testing to see, is it professional? Is it safe? Or you can do custom scoring to make sure that you're actually getting a good answer. And the other benefit of doing evaluation as much as you can is that, again, the quality of the GenAI system you're making is reliant on the good quality data that you have. And so if you have a data set that you begin with and you feed it to your app or your agent, you start doing these internal experimentations to see, is this performing the way we expect it to? And is it performing the way our users are expecting it to? We can then systematically evaluate this based on LLM as a judge and other metrics. And then we can have that in a monitoring scheme that will then improve the data quality as you go, and then back into creating a better app or agent. So again, I really encourage everyone to measure and track everything as soon as they can to ensure that you know that you're heading in the right direction and that users are satisfied with what you're creating. Okay, so a few sort of key points from this. I'll let you read it, but being able to test rapidly the different parts of your system, your AI agents, your LLM models, your embedding models, your tools, and everything that you're making in small modular compartments makes it really easy to ensure that you're creating something better every time you're iterating. Also, a lot of people want to or hear that their stakeholders want something that they can just ship out and try out immediately because everyone's heard of Cloud Code and everyone's tried Cloud Code, so they see how fast you can build stuff. The problem a lot of times is that it's not that easy to make something that looks good in a notebook and then just get it to 1 million users or 1,000 users. And so you need to be able to have that scalability of creating something that works quickly in an MVP environment and then taking that out to production grade. That's the key, and that's really, really difficult to do for a lot of people. And that's why I love working on Databricks when it comes to GenAI, because it's really easy compared to when we had to do it in notebooks. And then finally, when you're using Databricks, you actually have the ability to use external components and systems. I'll talk about that when I talk about the research that we did. But it makes it easy to avoid stuff like vendor lock-in. I know RagGraph, for example, is proprietary, meaning that you don't really have control over, well, after you built your system, then you still need to pay the bills in order to know if your system is working or not. And so having Databricks, you can just pluck everything from the Databricks platform, run it on your own, and not worry about costs at all. Okay. The second part here, I'll talk about the V case that we did for V. So they'd never worked with GenAI before we started talking to them. And they had a big problem of getting inclusivity into their core company. So just to summarize for people that don't know about V, there are over 7,000 employees in both Norway, Sweden, and I think Denmark as well. And most people know them for trains, especially in Norway, but they actually have a really big division that's operating buses across Norway. And the challenge that these bus drivers have is that a lot of them don't speak Norwegian fluently. And even if they do speak Norwegian, they're probably more comfortable in a different language. They have over 40 different languages that are being spoken by the bus area of their company. And so getting everyone on the same page when you're trying to give them documentation to do their work is really difficult. We saw when we were building the system that they had these bus drivers. They were driving along the road, and they had this huge bundle of documentation that was just printed out each month on the side of their steering wheel. And if you had a tire that punctured, or you needed to perform CPR, and you forgot, you had to skim through all of these pages of documentation that was printed out to figure out what you're supposed to do. And the other problem is that all of it is in Norwegian. So if you're struggling with Norwegian, you might have your phone with you trying to translate things live. And that's only if you know and read properly. Some people have dyslexia, and some people have challenges by reading the pages. So a lot of problems here. Effective information retrieval was hard. We had a lot of language barriers, and accessibility for reading and writing was also a problem. And what we see in Norway right now is that a lot of places in Norway are lacking in the amount of bus drivers that are applying to jobs. They don't have enough people. And so they're starting to lower the threshold of how much Norwegian or English you need to be comfortable with to get the job. And so together with V, we decided to try out generative AI because we thought that was a good use case for this. So we sort of had 4 main components of what we're trying to build. So we realized first that the best sort of use case for generative AI would be creating a chatbot where they could easily talk to their documentation in their own language, spoken, so you don't have to look at a screen while you're driving at the E8. And that is something that can be automatically updated as you go. So it needed to natively support over 40 different languages, everything that was spoken by these bus drivers. It should have a voice mode where you can talk and hear your replies in real time. It should always be updated with the latest available information. And we needed automatic evaluation to ensure that what we're building is actually hitting our customers' needs. This is a really, really common thing for developers to do, where you think that you know what users want, and you then solve for it. And when you're finally showing it to your users, they hate it, because you're not building what they're trying or they're in need of. For the architecture geeks out there, this is sort of the this is sort of how we set up everything. So, and this is simplified, I know, but we had our users' prompts coming from an iPad on their steering wheel or besides their steering wheel. We then hosted everything in AWS, and we had a translation and comprehension layer that would look at whatever the user is trying to say, translate it to the documentation language, which was Norwegian, give it to our AI agent, which would do a retrieval, getting the data out, and then giving it back to the agent before it gave it to the user again. The entire AI system was built inside of Databricks, which was really useful for being close to the data of the users and the feedback data. And everything was hosted in the same AWS server. I always know that not everyone is familiar with RAG, and I will say that word a few times, so I just want to make sure that everyone understands what it is. I know this is a bit small to read, but essentially the way it works is that whenever you're trying to talk to your chat agent, you want to make sure that it knows what it's trying to answer with. So for example, in the case of a bus driver, if I want to know how do I fix the tire of my bus, then I need to know that what it's answering is rooted in the documentation that it has access to, instead of it just looking it up from its internal memory. And the way of doing this is called RAG, which stands for Retrieval Augmented Generation. It sounds more fancy than it is, because essentially what it does is that it copies and pastes whatever is most relevant to what the user is asking about, and then pasting it into the context of your conversation with the agent. The benefit of this is that you can actually pinpoint what part of the documentation is this giving answers from. So you can tell it, well, I found this out from this part of the documentation. We found that we didn't really trust what our system was creating, because we had a pretty rudimentary proof of concept that we built for Norwegian, and it worked really well. We saw most of the time it was able to find the right parts of the documentation to answer the question. That's called recall, which is how much of the percentage of what, how many times was it able to get the right part of documentation to answer what the user is asking about. And but we didn't know how it was working for other languages. So what we did was that we just did a naive approach where we just told it, okay, you just need to figure out what the user is asking about, whatever language it is, and then figure out what parts of the documentation is relevant for this. So we translated the known good queries from Norwegian to a bunch of different languages. In this case, we have English, Polish, French, and Somali. And then we just ran the experiment with all of these different languages. And the more semantically different the languages was from Norwegian, the worse it performed. And so for Somali, you can see here that only 16% of the questions got an answer rooted in the documentation that it had access to. And this is sort of the crux of inclusivity when it comes to GenAI, because normally for a normal system, you look at this and then you just say, well, there's not a lot we can do because we don't know Somali, we don't know French, we don't know all of these different 40 languages. And so how are we supposed to create something that actually works well for all of these systems? But when we have GenAI, we have a lot of different strategies that we can implement to improve the quality of what we're building on. The first and probably obvious thing for a lot of people is that we looked at the models that were doing all of the heavy lifting for us. So when I talked about modularity, this is what I mean, where you can just say, well, okay, this is not really working as we wanted it to. So what if we just try out different models? There's a website called EuroEval where you can look at the performance of different models based on European languages. And I highly encourage you to look at that when you're building something, because you can see what's working for your users and not. And so that was the first part, just getting a better model. The second part is what's called re-ranking, where essentially what you're doing is that you're looking at what is the model spitting out, what documentation is it spitting out, and then how, and what is actually relevant to what the user is asking about. There's more to this, so I won't talk too much about it, but it's a really common practice for multilingual systems right now. Is there a lot of people here who use GitHub or have used GitHub? Yeah, most people probably. So whenever you're searching at GitHub for any sort of repo or code or whatever, you're using something called lexical search, where it's looking at the root word of your query, for example, Python, and then trying to find everything that's related to it. And so even though you're writing in a different way than what's normal, it will still find whatever you're trying to get at. So we use something called BM25, which where we took the lexical and the semantic understanding, and we combined the scores to get better results. And then finally, we tried something. I think we coined a two-path query translation, where you both give the model the original question in the language that the user spoke, and then you also do a translation layer where you do the same thing but with a translation and see how it works. And the idea here is that you make sure that you have both the actual question, but then you also don't avoid missing out on cultural context. And so with this improved version and a lot of experimentation, this is where we ended up with our final version. So you can see that most languages were hovering really high. And even stuff like Somali, we got up to 92%. So every single language that we tested for got over 90% accuracy for recall. This is sort of what I mean when I talk about building something that's just a proof of concept, and then building something that's a proof of value, where you can actually measure and quantify how is this performing across the board. And this is also what I mean about inclusivity, where you can make sure that everyone that's a user of the system that we're creating has the same access to what we're building. It's not just something that we were creating for Norwegian speakers, it's something that we're creating for everyone equally. So this is the current status. They did a pilot last year, which was performing pretty well. And they actually ended up using it for all of their internal training for new employees. They have tested thousands of questions so far, and the quality is still over 90% of all of the different languages. And this has really opened up V's appetite to work with GenAI. So now they're widening their scope for GenAI systems. The last part I want to talk about is what we've been doing internally at Knowit. So we've been working with GenAI for, I guess, over 2 years now. And there's a lot of things that we've learned. And we've also learned that the use cases and what our customers are looking for is not always something that's easily accessible from a proof of concept. So based on all of the knowledge that we have, and based on all of the experience that we have from Knowit, we developed something we call Folk GPT. It makes more sense for people at Knowit, but we have an internal system for accessing information from everyone in the company that's called Folk. And this was created when ChatGPT was more popular, so I guess that's why it's called Folk GPT. When you work as a consultancy, we have a lot of data about everyone in the building and outside of the building. All of us have a really, really large resume that's tens of tens of pages long. And it contains information about everything that we've ever done for a project, who we worked for, how many hours we had for it, etc. And so when our sales department and marketing department and all of these people were trying to access that data, it was really hard to figure out who actually did what and what kind of systems or what kind of projects that we did do for GenAI or for MLflow or for other things. And so we wanted to create something where everyone in the company can easily access the same information, and you can get more knowledge about what we're actually doing in the company. We ended up building a Slack agent, and the reason is because most people don't want to change the way that they work to get something that they need. They want to be in where the work is being done, if that makes sense. So if you're working in Outlook all day, you want to be in Outlook when you're trying to use a chatbot. When you're a developer, you don't want to have to go into cloud.com or .ai to access a chatbot. You want to have it in the IDE. And so here is an example where I'm asking it which one of our consultants is currently between projects. And so it does a tool call here, trying to figure out which part of the database contains that information, and then it gives it to you. And then I obviously can't give you what it's saying here, but I can. You can do more stuff. So you can say, okay, well, based on the context that you just gave me, let me ask other stuff like, okay, we have a bunch of available consultants right now. Which one of them knows Databricks? And then it will look at the information it got from the previous call and then use that to answer the second call. You can also do other stuff. So we have tools that we created for it. For example, I want to create a sales pitch for the V case that I just talked about. It thinks for 12 seconds, and then it creates a PowerPoint here based on our internal template with the right font and the right colors and everything. And it finds a good photo. And then it gives you an AI-generated summary of the project. And this is really useful because then you can, with Folk GPT, you can have it contact the people that are responsible for the project so that they can verify before sales use it externally for their system. Obviously, because I just talked about how important evaluation is, everything that we did was based on evaluation scores and metrics. I know this is pretty small, but on the left, we look at recall again to see how good is it at finding the right information to answer the question. And on the right here, you can see user feedback. I'm the only one leaving user feedback right now because I'm testing it. That's why it's so bad. We also have a bunch of other goodies that you get from MLflow. So because every single user query is being tracked, you can look at stuff like how many people are using it, what time of day are they using it, how slow or good is the system at answering those questions, and how many tokens are we using. And all of this is really relevant for us because we're, again, running everything on our own servers. So the way we set it up is that we have a Databricks instance where we have all of the information from our company. And from all of these different sources, we're putting it into Databricks, unified, and then we're getting that data down to our server here. And in the server, you have a Ollama instance that's running the actual inference. We have our database, and then we have a Postgres, or our Postgres being our database, and then FalkGPT being the application running. Then we have a hook for Slack, which posts these queries to our data, or to our database, and then giving an answer based on all of this. And so everything is running locally, except for Slack and Databricks. But if you sever these connections right here and here, this will still be running, meaning that everyone in the company can run it at any time. And you don't need to be in the office to use it because Slack is in the cloud. So it's a really nice system because you keep availability at all times, but you also make sure that you don't have an external model that's running. You don't have anything that's being sent from sensitive data to an external provider. If this building burns down, this system burns down with it, which in this case is good. I also wanted to show some alternatives that we have. So again, because everything is so modular and the way we set it up is modular, we realized that we wanted to ensure that people can just take this system and then put it into another project and have it running immediately. And so this is, for example, how you could set it up for Databricks applications or apps, where everything's running in the Databricks cloud. Or you can bring your own cloud, AWS or Azure or GCP or Hessner or whatever. Or you can have it running on whatever vehicle you want. You can bring this to a Snowball, AWS Snowball, and have it running on a aircraft carrier, or you can have it in your basement. It's really up to you. So to summarize, we realized that when you're building for GenAI, one of the most important parts is having something that's reliable and that can be easily interchanged. I often look at the AI or GenAI technology sphere, and I think about all of these systems as people falling down from a airplane, where you don't really know where they're going to land yet. You don't know if Langchain is going to be relevant in a year. You don't know if MLflow or Databricks is going to be relevant in 5 years or 10 years. So whatever you're building, make sure that it's easy to swap and change so that you can both keep reliability and you can make sure that you're actually solving the original problem or challenge from the user. That's me. Thank you.
Questions? Wow, two really fast persons, people in plural, or persons.
Really nice presentation, and one of the things that I was thinking when you were presenting about the V use case on translation on demand, right? Did you have a chance to look at running the RAG on translated documents? And if you did, how was it? Like, was it a huge difference in the output or the quality of the output?
Yeah, good question. So to summarize, we started by translating the question from the user and not the actual documentation, which is what the question is about. And we did try it for English, and we realized that English is a really good source language to have the questions in, because it's way easier, or most language models are based on English data or texts. And so we actually got a lot better with a lot of languages just that way. We didn't try it where we translated to all of the 40 different languages because it's just too much data. And we didn't see that we had such a... we didn't really see a good improvement in quality. The biggest problem we saw is that we don't know how we can verify that the translation is actually accurate. And so the problem was, how do we make sure that we're just moving the problem to how good is our translation layer. So to avoid that, we had both running at the same time, and you can't really do that with that approach.
Because on demand, because when you translate on demand, it's also about the token usage. That's extra token usage, and probably if there is a similar question, so it's by another user, so you're translating it on demand, maybe twice. That's one thing. Also, the second one is some models are really good at Somalian. Some models are really good at like Norwegian, purely trained on Norwegian language or Somalian language, for example. Is it better to use on the translated documents, or is it just the same output quality? Again, the same question.
Good question again. So the first part, again, are we using a lot of unnecessary tokens when we're doing the translation on demand? And the answer is no, because we're not using an LLM for the translation. We're using AWS Translate, which it will cost you compute, but it's negligible compared to what you're getting out of it. So it wasn't really a problem. The second part, which is also pretty interesting, is the question of how, can't we just use different models for different languages? We actually have one of the people working on the project was responsible for creating the Norwegian whisper model. And he's been working a lot with different types of AI models for Norwegian. And we tried substituting just the Norwegian parts with that model, but it was too finicky and we didn't really have an answer for scalability. So we decided that we just wanted to use the model for everything, or one model for everything. Yes, good questions. Yep.
Yes. Do you need to change the original documentation to make things more efficient? If you, for example, need to add some tags, label, comments to help the model, for example?
Yeah, good question. So we realize, and I think everyone who works with GenAI at some point will realize that the data that they have isn't good enough. So we found that early on we tested for a bunch of different queries that the bus drivers wanted to know. And we got a bunch of them wrong. A lot of the answers it just didn't have. And so we started to think about which part of our system was not working as we wanted it to. We found that our users didn't have the data in their documentation to begin with. So it didn't know stuff like who is your immediate leader, for example. It didn't know who you're supposed to call in the case of an emergency. So a lot of the back and forth with our client was just to figure out what data holes do we have in this data. I think that's sort of like mostly what you end up realizing when you work with GenAI. We did do some transformation of the data where you have a chunking algorithm that it finds out which parts of the documentation belong together. You can do a lot of finagling about how that works the best. But in general, it's mostly about filling those data holes. Yeah.
There's the microphone.
Yeah, just to follow up on the chunking and indexing, that's always interesting. And you said it's high velocity or relatively high velocity text documentation.
Yeah.
I was curious if you did any smart pruning, or if you did like more naive document-wise pruning when new documents are coming, and also kind of the indexing process there, because I assume there are some end users on the other side uploading this document when it's updated or whatnot. So kind of how did you focus on like the interface there, or was it already in place?
Good question. So I'll answer the second part first, which is about uptime basically for when you have documentation that's being updated versus uptime for the actual system. So we had a dev prod split where you have a developer part of the system, And we realized that the chunking could take a while. I think we ended up with half an hour, sometimes an hour, to chunk all of the documentation, meaning that you have it in a vector base so that your AI system can query it. And you need to have constant uptime. We probably could have gotten away with doing it at night because most bus drivers aren't driving at night. But because the actual system was so sensitive, again, I think, my opinion, but if you're a bus driver, you should probably not ask our AI agent how to do CPR. But it could answer that question, meaning that we needed to have something that would work at all times. So we did a database migration where we migrated the development arm of our system over to our prod part as soon as the testing and evaluation was complete. So that's the way we kept the downtime to as low as possible. So you're just pointing it at a different database. And sorry, the first part again.
It was kind of just the document upload part. Was it an automated part, or was it like manual labor from stakeholders?
This was a really big part of tension to begin with for the project, because obviously the client doesn't want to ever have to think about this system existing at all. But as soon as you have automated uploading of new data, you can have something where it's called data drift. So your original data might not actually answer the questions that the users have anymore, or it's faulty or something went wrong. So we went with sort of a half automated system where when the user gave us their new documentation, we automatically ran it through all of the evaluation harness to make sure that the quality was at par with what we expected it to be. And if it wasn't, we automatically sent a answer to the user saying, hey, this is not good enough. And if it was, we had a manual process to say, okay, this should be pushed to production or not. Yeah. Do we have time for...
One short question, yeah? Or ask you and then one more. So,
yeah. About the RAG system, have you used Mosaic, or did you build some custom material? Because we did that as well for a project in SRS, and we saw that unless you have a very huge document base, so with like thousands and thousands of pages, actually like the performance is like if you just implement a standard cosine similarity, it's a bit faster.
Yeah. We saw the same thing. Is it long ago that you tried this?
December, I would say.
Right. So when we started building, the most annoying part was that Databricks would update everything every 2 weeks or so. Either the new name or a new name again. But we realized pretty early on that having everything in Mosaic was detrimental because you have the same vendor lock-in problem that you usually have. So we've had a custom harness sort of in their way of doing things with serving endpoints and everything. But I think now if you try it, I think they have improved slightly. Maybe you can ask Julia or Paul afterwards.
Final question.
I can just speak.
Yeah.
How did you handle hallucination? How did you handle hallucination? Did you implement guardrails?
Implement what?
Guardrails.
Yeah, okay, so how did we handle hallucinations? We were really scared about hallucinations to begin with. That's why the most important metric for us was recall, which says how many times does it answer a question with the actual information to answer a question. I think one time we saw it hallucinate. It found a person that didn't work there anymore. But then we realized that it was because Databricks was caching some of the data in the back end. So we actually didn't have any sort of big problems when it came to hallucinations. I guess like the most important part is again recall, and also we thought about trying to prune the model, but we realized again like it wasn't really that big of an issue, and I don't think we've gotten a single feedback based on hallucinations. So, but I think some products for AI is more sensitive for hallucinations than others. So I think it depends. But we would try fine-tuning if we had a big problem with it. Yes. Okay. Thank you so much.